Let's recall our list of the formulas for the derivatives of the inverse trig functions that we learned about last time. So here's the list. So I want to call your attention to just this first formula that's on the list, and that's for the derivative of the arcsine of an expression of a variable x. So we're letting u represent that expression. And so what this formula says is that the derivative of arcsine of u is going to be the derivative of u with respect to x, u prime, right, divided by the square root of 1 minus the expression squared, 1 minus u squared. So if you let u be a very simple expression, namely just x, then of course this formula simplifies somewhat, right? The derivative of x will just be 1. And then, of course, this denominator will be the square root of just 1 minus x squared. So that's the formula that I want to prove for you in this next example, example 6. I actually want to show that the derivative of arcsine of x is going to be 1 over the square root of 1 minus x squared. All right. To show this formula, let's choose a variable for arcsine of x. So I'm going to say y is equal to arc sine of x. And the reason I'm doing that now is because I'm going to translate this expression, this equation, back into the inverse function for arcsine, which of course is sine. So you know from our knowledge of inverse functions, right, that if y is equal to arcsine of x, then that means that the sine of y is going to be equal to x, right? Just going to switch the input and the output variables, and in the inverse function, which is sine. Now, we're going to use this equation actually to derive the derivative of arcsine of x. Let me show you how. All right, so what I'm going to do is, let's write down here, I'm going to take the derivative of both sides of this equation with respect to x. Let me write that out. So I'm going to take, again, the derivative with respect to x of sine of y, and then also the derivative with respect to x of x itself. Well, of course, the derivative with respect to x of x is simple, right? That's just going to be equal to 1. But now taking the derivative with respect to x of sine of y is a little bit trickier because, see, the variable we have in the sine function is y, which itself we're thinking of as a function of x, namely arcsine of x, right? So we have to recall our knowledge of implicit differentiation back from your Calculus 1 course to help us find this derivative. So I hope you can recall a little bit about implicit differentiation from Calculus 1. So to start finding this derivative, well, we just find the derivative of sine of y. That's easy, of course, because derivative of sine is cosine, so we get cosine of y. But now here's where the implicit differentiation comes into play. We're going to have to apply the chain rule here in calculating this derivative, because y is a function of x itself, right? So I'm going to multiply by the derivative of y with respect to x. I'm just going to call that y prime, or we could call it dy over dx. But either way, we have to multiply in this derivative of y with respect to x. So we actually get that cosine of y times y prime is equal to 1. And now you can simply solve this equation for y prime, right? So we get y prime is equal to 1 over the cosine of y. So here now we have an expression for y prime. Remember, y is arcsine of x, so y prime is going to be the derivative of the arcsine of x, right? So there we have it written down. There's our expression for the derivative of the arcsine of x. But I need to write that in terms of x. not in terms of y. So I'm going to have to actually here translate cosine of y back to the variable x. Now, this is where a representative right triangle can help me, like we practiced in some of the early examples. See, since we know that sine of y is equal to x, right, we can think of y as being an angle in a right triangle. So I've drawn that representative right triangle here, and of course I have inserted y as one of the angles. And since sine of y is equal to x, of course, sine in a right triangle is the opposite of an angle over the hypotenuse, right? And so we can write x as x over 1, and then that allows us to label some of the sides of this representative right triangle. I can label the side opposite of y as x, right? Okay. And then I can label the hypotenuse here as 1. So that when we take x divided by 1, opposite over hypotenuse, we get x, and that's the sine of y. All right, now, because we know two legs of the right triangle, of course, now we can apply the Pythagorean theorem to find the adjacent side to y. And I'm not going to write out those calculations because we've done them before, but when you apply the Pythagorean theorem and solve for the adjacent side, you're going to get the adjacent side here is going to be the square root of 1 minus x squared. Well, now, that's what allows us to calculate the cosine, correct? Okay, because the cosine of y is going to be the adjacent side over the hypotenuse. So cosine of y is square root of 1 minus x squared divided by 1. That's just square root of 1 minus x squared. So now we can fill that in for cosine of y. So we get 1 over the square root of 1 minus x squared. There it is. So there's y prime, which is the derivative of arcsine of x, right? Okay, because y is arcsine of x. So we have derivative of arcsine of x is going to be 1 over the square root of 1 minus x squared. Exactly the formula, right, that we have written in our list.